Pre-cal babies, we are still in Unit 9, Vectors. You know it. So in this video, we are going to define what a direction angle is, and we are going to use our steps for finding direction angles. I know you're very excited about this, so try to calm down. All right, so what is a direction angle? So I've got it typed up here for you. It's the angle formed by the positive x-axis and the vector. And what we do is we move counterclockwise from the positive x-axis to the vector in order to do this. So for your steps, the very first thing we're going to do is determine the quadrant in which the vector will be and draw it on the coordinate plane. We're going to use the signs given in the component form to determine this. So we're going to draw the vector. That's the first thing we're going to do. So let me draw a coordinate plane for you here. And we are just going to go through these steps as we go through example 1. That's the best way to do this. Okay, so I know y'all don't like the black marker, so we'll switch it up here. Okay, so number 1, we are going to draw in the vector. So I've got vector v, and it is -5, 4. So I'm told to use the signs given in the component form. Well, this -5 means that from the origin, so from 0, 0, we move left 5, and this is positive, so up 4. So left 5 and up 4. This does not have to be to scale, by the way. So I just want you to know that. All right, so this right here is my vector. So I moved 5 left and I moved up 4. So notice what happens here. It forms a right triangle. Magic, okay? So notice that I left the negative off the 5. We can't have a side of a triangle that's negative, so the negative just tells me the direction to go. All right, so think about that. So we're using the vector as the hypotenuse, and there's our right triangle all drawn in for us. We are going to label the angle inside the triangle at the origin with the Greek letter theta, just like that. I did not do a very good job with that theta, though, did I? No, Miss Griggs. There we go. That's better. Okay, so there's theta. All right, step number 3, theta represents the reference angle, and we will use tangent to find its value. So the tangent of theta is going to equal the opposite, right, over adjacent. So notice that for this particular situation, that is going to be the y value over the x value in our component form, okay? So just keep that in mind. So I'm using tangent theta of 4 over 5. And remember, these are sides of a triangle, so I'm just using their positive values. So then in my calculator, or in Desmos, I've got to find tangent inverse of 4 divided by 5. So what I get for theta when I do that, I get 38.7 degrees. So that's what this angle is right here. We're not done. That is just the reference angle. Okay, so this is the reference angle. And remember, I've drawn you some notes here. Remember, reference angles, we've talked about these already. They're always positive, they're always acute, they're always on the x-axis. So this is a reference angle. Once we get the reference angle, now we're ready for the direction angle. The thing to remember about the direction angle is that it always, always, always starts at the positive x-axis, and we move counterclockwise until we reach the vector. So the direction angle is right there. So this is the direction angle. The reason we needed the reference angle is because the direction angle in this particular situation plus the reference angle is 180 degrees. So if I take 180 degrees and subtract the reference angle from it, I am left with my direction angle, which is this angle right here. So that's 141, oops. It's not 141, oops. It's 141.3 degrees. There you go. That's how you do it. Easy peasy, lemon squeezy.